All right. Thanks for joining the session 2. We learned in the first session about the RAG, how the LLM is going to work for your enterprise system, and then what is mean by RAG, and then I showed the quick example as well. Now, as part of the part 2, we are going to discuss about vector database. Okay. So, vector database. What is mean by vector database? First of all, where we are going to use the vector database in your RAG architecture, or you can say RAG pipeline, I'll be showing to you, right? So in the previous example, I showed you like as soon as you open a chat GPT, you open a new chat, which is a context window, they call it as. Okay. So in the context window, we attach the sum of the context, which is like maybe your company policy, leave policy. So you attach the policy and ask the questions. As soon as you ask a question, it's going to read the details from your attached document and then it's going to respond. That's how the simple RAG without programming language I explained it. Now we are going to do programmatical way. Programmatical way means, so let's say if you have a 100 GB of document, you cannot able to attach it, or you cannot able to put everything into a single API call because context window is very, very limited. So you cannot attach complete 100 GB of data, right? One is a context window is too small, and then you will get a so much of bill, and then you are going to stress the AI lot, LLM lot. That's not a right approach. That's the reason we were going to use the vector database. What vector database basically it's going to do? It's going to chunk your policy data into probably 200 to 300 tokens. Token means in the sense for now you can consider as a one word is a one token. So, or maybe, yeah. And then uh, chunk it, store it. As soon as you do the search, it's going to search meaningful, basically a semantic search, and bring the top 10 record, top K record, whatever the 100% matches, it brings up that contextually, it's going to send it. In this example, let's say user asks the question, right? And then vector database, it's going to search it particular record meaningful, basically. Let's say if you search kind of like how much leave I have, a leave related record per year, those kind of meaning, it's going to search it and going to bring up the record, bring up the top K record. And then that will be pushed into the LLM. Based on top of that, your question, it's going to respond your answers, right? So that's what I'm saying. Then find a top K record and then it goes to the LLM and then it will answer it. So here we are talking about the PDF database wiki API. So database and API is going to be a different chapter that I can cover it up in the part 3, agentic RAG. How are you going to do the connecting the database, MCP, all the stuff. But this one, we are going to do the simple basic RAG. Hope you understand. So basically document or PDF or otherwise wiki or all together also you can keep it in the vector database. It's going to respond. So what is vector database? So where are we going to use the vector database? We just saw that. And what is vector database? This is what we are going to speak about here. As I said, it's a specialized database built for AI. Okay. And then store and search data by meaning. In your regular database, we all know that if you query, it's going to respond what are the equality match. Let's say search, probably select employee star from employee table where employee ID equal to 1 to 3. It's going to bring up that particular record only, right? Basically, it's going to search equality match. Exactly equally whatever the matches, it's going to bring up. If it is matches a one record, it's going to bring up one, or if it is a multiple, it's going to bring up the one multiple record, whatever it matches. But here, vector database, it search by meaning, not an exact keyword. That's the one of the interesting topic. So how it do that? We are going to do the little bit, I'm going to explain more about that, how it does it on the backend. Optimized storage. So as I said, let's say if you have for an example, you have 1,000 line, right? 1,000 line of one document. So it's going to break it into a 200 line, probably 4 record, and then do the embedding. What does it mean by embedding? There is a model, embedding models out there. It's going to call the embedding model, convert that text into an integer, decimal numbers, and then that decimal number would be stored into the another column, right? So one first column is going to be a text, another column is going to be a number. That's what they are saying, the stores high dimensional float array efficiency with the metadata. And search, find the nearest neighbor. So as we told that it's going to convert into a decimal. As soon as you ask a question, that itself convert as again using the embedding model, convert to integer nearby whatever the integer. Let's say you search a text that is 1.2, and then it's going to find whatever the nearby 1.3 is there. It's going to bring up the 1.3, right? That's what it is going to find in the top k record, as I said. And then it can be scaled into the millions of record, as I said, not just only 1,000 record, 1,000 lines of the document. You can load it into a vector database, probably a GB level of data, also chunk it and store it. Just one pipeline, if you set up, it's going to run it for one day, and then or maybe a 2-3 hours, right? All the chunking is embedding is done. It's just one time it's done. And then later on, if you update any document, then you just need to update it. That's it, nothing else. And then as soon as you do the search, it's going to bring up 1 or 2 record, maybe 4 or 5 record, and then it's going to put it in the LLM and get back. That's going to be you're developing a small brain into that. And then there is a metadata filtering also there. You can set up some kind of category, another column, so that it bring up those kind of data, so that it will be much more faster. Okay. So we just saw that. Now, what are the embeddings? So how the embedding is going to work? So raw text, we have to chunk, as I said. The industry standard is a 300 to 512 tokens. And then using the embedding model. What is the embedding model? So embedding models is like most powerful or most used model is a Hugging Face. And then OpenAI also, they have their own model. So that it will convert your text into a decimal format. They call it as a embedding. And then this is how it's going to be a vectorization representation. As I said, this what is meant by semantic search. Car and automobile is going to be the same meaning, so that will bring up the closer vectors. I need help equal to can you assess me? It's also going to be exactly the same. That's what it's going to find it. So I'm going to give you one classic example. Here the classic example. Actor, the word is below is the decimal representation. And obviously actor is a man, we know that. So if you minus with the man is, this is the number. If you minus with that, and then plus woman equal to actress. So you got the point right now, right? It's all completely a mathematic behind the scene. Again, I'm explaining here. You can pause the video and then look at closely. You'll understand it, how it's happening. Actor is a male, and then minus male number. Consider actor is a 1, and then male is a 2, and then you minus it, and it's going to be a 1. Probably woman is a 1.5, and then plus 1 plus 1.5 equal to 2.5. It's actress, something like that. Hope you got it. This example will clarify. I hope it would be clarify you very, very clear way of it. Right? Next. embedding creation pipeline, right? So how the embedding creation pipeline helps you. So as I said, so there will be a two level of project you have to create. One is the pipeline, which is going to be a huge number of document that you will be chunking always, and then do the embedding and then storing into the vector database ready for search. Another side, it's a one side is a backend code, another one is a client side code. In the client side code, you will be searching the word. In the vector storage, you will bring back the top k record. I'll show you the quick example how it works. Okay. In the end of the session, I'm going to show you that. So this is how the vector database would be look like. So one is a document ID. As you all know, we'll be storing the unique ID. And then the vectorization, it's going to be a decimal numbers with the source text. Probably you'll be chunking with it. This is a metadata. The metadata is optional, whatever you want, you can do. The actual data would be like this. Here, there would be another column. It'll show up like this number is a representation of what, this number is a representation of what. This is how it will be look like. Semantic search architecture. So this is the other way, the chat based service, what I'm talking about. User enter the question, it's going to hit the embedding model, convert it, and then once you convert it, that number would come, and then it's going to search the vector database. It's going to bring up the top k record, probably first matches record, and then top similar result it's going to bring it. That value is going to the LLM, and then it will bring back the answer, right? So this is all about the vector database, right? And then here is the Microsoft stack, right? Microsoft have the Cosmos DB. You can use the ChromaDB as well. Azure AI search is the OpenAI search. You can use the whatever other LLM access also. And then Microsoft Foundry is going to be give the complete package for that. Well, you can plug the vector database, you can attach the source, you can put the embedding model, and then you can immediately you can do the searching model, everything you can able to do that. These are all the orchestration frameworks. So orchestration frameworks, what does mean by orchestration framework? LangChain we have, LangGraph we have, Llama Index, and MCP is a different way of it. I'm going to show you the MCPs completely on the next session in the agentic RAG. But LangChain is the one what we are going to do, what we did like document and then document Q&A, conventional agent, tool using pipeline. These are all the simple lang chains like connecting the vector database and then connecting the LLM, get back the answer. There's a lang chain. Agentic RAG is the lang graph. It's going to take a decision on the agent own, like it's going to have a parent agent and then it'll split the multiple children agent, and then based on that it's going to take a decision, and then based on the answers parent is going to give back the answer. These are all the stuff the lang graph used to work. MCP, as I said, now we are going to develop the simple basic RAG. MCP is like personalized RAG if you want, based on that DB context you are going to add, or maybe some other tool context you are going to add. Those things MCP would be covered. This is developed. This is invented by the Anthropic, and that's all it is. So let's look at the mini project. Okay. I hope you can see my screen. So in this screen, uh, on the last session, we saw the demo, right? How many PTO I will get every year, right? So for full-time employee, 15 days PTO per year for first 3 years. This is the data we got it, right? And then how it comes based on the source document we have here. leave policy, onboarding process, remote work, frequently asked question. These are all the data. We chunked it basically. How we chunked it, I'm going to show you that. This is how the all record which stored in the backend database. Backend database is ChromaDB. I'm using the Microsoft one, ChromaDB. Sorry, it's a ChromaDB is an open source one. Cosmos DB is a Microsoft database. Here, the leave policy text is converted into a chunk 0, right? Which is because I'm using a 200 as a token size. So if you see that this is one of the chunk, and then another chunk is going to be a chunk 1. If you look at that, one more point I would like to tell that we are doing the first 80 character, the overlapping is doing it. Then only it's going to work very, the response is going to be a more appropriate to understand the meaning. If you look at that from completed to this, completed to that leave is a forcible. So this complete sentence, we just overlapped. If you look at that forcible till the forcible, and then the rest of the document would come. So as I said, this is a one of the policy document, and then second, third record is going to be a different document. So there is no overlapping. This is a fresh document, and then the another record will have the definitely would have the overlapping. The same way it's going to work. These are all the vector representation of it. There are more is there. Correct? I hope you all understand that. It converted as a totally 6 record. And then here I'm going to explain how it's bringing up the record, right? Look, it whatever the leave matches, it bring up all the records, right? Because it searched based on the meaning, but it will pick up the highest score. This is the highest score if you look at that. So leave and time full-time policy is 15 days. Here we have the answers for the question whatever we asked. So this context only it will go into the LLM and then it will bring back the answer, right? So it doesn't need to go send always all 3 documents. So whenever we ask a question, this is the only data going. Look, this data we saw that based on that context, LLM is just rephrasing and then responding it. That's it. This is all about the vector database. Let's go back to the deck. Yeah. I explained how the document, how the chunking, and then vector database, how it is the embedding happen, how the vector database query search, and then AI response, everything we just saw. I'd like to quickly show you the last video chunks. 1 minute, really quick. Yeah. So how the entire application works, the leave policy, all 3 document, it goes into this document. OpenAI is going to using the OpenAI embedding model. It just goes in and then stored in the database. As soon as you ask, this is a UI, the policy assistant. As soon as you ask, okay. So with that, we are going to close the session. Thank you so much.